So now let's get into the squeeze theorem, also known as the sandwich theorem. If we can show that some function f is squeezed or sandwiched in between functions g and h for some open interval that contains c, and that g and h both have the same limit as they approach c, then we can conclude with the squeezing theorem that the limit of f must also approach that same limit because it is sandwiched in between those two functions around that value. So let's look at this example below. We're going to use the squeeze theorem to show that this limit is true. So the first thing I want to do with the squeeze theorem is bound a part of my function. So I'm going to start with bounding this trig function here. I know that cosine of 50 pi over x is between -1 and 1, but that is only for all x not equal to 0, because at 0 there is a vertical asymptote. So let's just remind us, this upside down a I read as for all. Okay, so we're focusing around 0, so this is true for every value except 0. So now I'm trying to create x times cosine x. So what I could do is, in this inequality, multiply each piece by x. And the inequality still holds true for all x not equal to 0. So now I have created our limit function squeezed in between two functions around 0. So now let's check the limits of these two outer functions. So I know the limit as x approaches 0 of -x equals 0, and the limit as x approaches 0 of +x equals 0. So those two are equal to each other. So therefore, the limit as x approaches 0 of x cosine 50 pi over x must equal 0 by the squeeze theorem. And we must note that that is true for all x not equal to 0. So it's okay that at 0 it might not equal 0, but around those two, around 0, it's approaching that value.